Hi, welcome back. In this video, we're going to talk about the law of sines. So far, we have been mainly focused on right triangles. We've done Pythagorean theorem, special right triangles, even SOHCAHTOA, right? We will no longer be able to use SOHCAHTOA because we're not going to be focusing on right triangles anymore. So, we're going to shift our focus over to law of sines. So as you see in this picture, we have an obtuse triangle. If you have an obtuse or an acute triangle, we can use this next formula, the law of sines. Technically, this formula also works for right triangles, but usually we only need the law of sines when we're introducing a different type of triangle, like this one. The first thing we want to understand is we're going to want to label our triangle where our angles are labeled as capital letters. Now, the size of the angle, like angle A as an example, opens up and determines the length of the opposite side, right? The bigger the angle, the bigger the opposite side is going to be. The smaller the angle, the smaller the opposite side. So, since the angle corresponds with its opposite side, we're going to name the opposite side length lowercase a. Similarly, angle B opens up to this side. So we're going to label that angle lowercase b. And angle C opens up to the other side. We're going to label this one lowercase c. Now what's really interesting about the law of sines is that since the angle determines the opposite side, the ratio of the sine of the angle and the opposite side will be the same for the entire triangle. If I take the sine of A and I divide it by the length, it'll equal to the same ratio as angle B to the opposite side length of B. And the same thing with angle C and the opposite side of C. And the formula looks like this. As long as we are able to label the picture with the angle and its opposite side, we're going to be able to use this formula, law of sines, to solve for a missing side or a missing angle. So let's do a few examples. And if this video was helpful, make sure you press the like button. And of course, subscribe. So here's a scenario. As you can see, we have an acute triangle. We're trying to find the length of AB. Before we do so, we're going to label the opposite sides to the opposite angles. So angle A is opposite to side A. Angle B is opposite to side B, so B equals 7. And then C, of 53 degrees, is opposite to side C. These are all lowercase letters. I'm going to put my formula here in the top. Sine A over A equals sine B over B, which equals sine C over C. Now, because I'm only missing one angle, I can technically find that angle already. The whole angle, all of the angles in a triangle will always add up to 180. So we can just say 53 plus 44 and subtract that from 180. And we can quickly calculate that this is an 83-degree angle. Now, when we're using this formula here in the top-hand corner, the first part of the formula that we want to use is the side that we're interested in looking for. Since we're looking for finding the length of AB, which is the length this side, right? We're trying to find side length C, this side on the right. We're going to use this part of the equation. Because we're looking for C, we will always have to use everything that belongs to C. Therefore, we're going to use this piece of the information. We're going to write the equation. The first part of the equation will be sine of the angle divided by the side. Now we get to decide which other one do we use. Are we going to use sine A over A or sine B over B? Well, what information do we have? As you can see, we do have angle A, but we don't have side A. We do have angle B and side B. And since we have both sets of information, we're going to use the second part of the equation. Sine B over B. When you're solving this, you only need to have two sides of the equation for you to be able to solve. Once you identify the equation, we're going to plug in the variables that we know. We know the angle of C, so we're going to put it in as sine 53 over side length, which we don't know. And then we're going to plug in angle B, which is 44, sine of 44, divided by opposite side, which is 7. Notice here how we only have one variable, C. You can always solve an equation with one variable. Now, all we're really dealing with here is a proportion. So, how do we solve proportions? We cross multiply. We multiply the C over to this side, and we multiply the 7 to this side. That makes it 7 times the sine of 53 equals C times the sine of 44. Now that the fraction has gone, we can solve for the variable. And since we're multiplying on the right side times sine of 44, we're going to do the opposite. We're going to divide by sine of 44. This allows us to isolate the variable as 7 times the sine of 53 divided by the sine of 44. Now that the variable is isolated, this portion we can do in the calculator. Make sure your calculator is in degree modes, and we have 7 times the sine of 53 divided by the sine of 44. And that gives us about 8.05. Now, hopefully that also makes sense. Since angle C is 53, we know that this side should be bigger than this side because 44 is smaller. So if 44 opens up to size 7, that means that C should be bigger than 7. And we did. We got 8.5. I'm about to do another example of finding a missing side length. If you want, you can press pause, try the next example on your own, see if you're getting this. If you're understanding how to find the side and you want to skip over to finding the angle, go ahead and fast forward a little bit to the second half of this video. Here we're looking for side length AC. So I'm going to label things. Across from angle A is side A. Across from angle C is side C, and across from angle B is side B. Since I already have two of the angles, right, 118 and 22, I can find angle C already. This angle, 118 plus 22, is 140. When we subtract that from 180, we're left with 40 degrees. If I'm able to find a missing angle, I will always do that immediately. If I'm not, then I don't have to do that part. Okay, so here we're looking for side length AC. AC is this component. So we're trying to find the length of little b. Since I am doing that, I know for sure from my equation I will have to include sine b over b, since I'm solving for this piece. That's always going to be my first setup. I'm solving for b, so I have to include that part of the formula. Now, which other one do I include? Do I use sine A over A or sine C over C? Well, this is where it comes down to our picture. What information do I have? Notice how for angle A, I have the angle, but I don't have the side length. But for angle C, I have the angle, and I have the side. And that's why I'm going to use sine C over C. Once I identify the equation that I'm going to be working with, I plug in my information. The angle for B is 22 degrees. The side of B we don't know, we leave it as a variable. The angle for C is 40 degrees, and the side of C is 24. And again, we have a proportion. So we just cross multiply. Cross multiply gets rid of the fraction. We have 24 times the left side, sine of 22, should equal b times the sine of 40. Now that the fraction is gone, we can isolate the variable, which is b. Since we're multiplying, we're going to do the inverse and divide by sine of 40. That allows us to isolate the variable. b equals everything on the left. When the variable is isolated, that's how you know you're ready to go to the calculator. plug everything in the calculator on the left, and you're able to solve. So we have 24 times the sine of 22 divided by the sine of 40. And that gives us about 13.98, which we can round to 14. So these are the two examples on how to find the missing length. If you would like, you can always pause it, go back, try the problem on your own, and see if you're getting the hang of it. Let's talk about now how to find a missing angle. As you can see by this example, I'm now searching for angle B. Sorry, angle C, which is right here. I'm still going to label everything that I know. So across from angle C is side C. Across from angle B is side B. And across from angle A is side A. Notice how for this one, because I don't have two angles, I can't find angle C or B by adding numbers and subtracting from 180. I don't have enough information. But I'm still going to be using my equation. Sine A over A, sine B over B, and sine C over C. Since I'm solving for angle C, I know I have to use this part of the equation. Sine C over C. Now, where else do I have more information? Well, angle A and side A is given, so I can use that. Sine A over A. So let's plug in what we know. We don't know the angle for C, so we're going to leave it as C. I know the side length of C is 21. Angle A is 88 degrees. And side A across from it is 26. Always plug in what you have and then cross multiply and solve for the variable. When you cross multiply, we're going to have 26 times the sine of C equals 21 times the sine of 88. Solving proportions, we always cross multiply, and then we can isolate the variable. We're solving for C, so since we're multiplying by 26, we're going to divide both sides by 26. That gives me sine C of 21 times sine of 88 divided by 26. Now, since we're solving for angle C, how do we get rid of the sine? We have to do the inverse, and that's where inverse sine kicks in. So I can take the inverse sine of the left and inverse sine of the right. This is going to allow me to get rid of the sine and leave me just with the angle. C equals sine inverse of everything on the right. As you saw in our previous videos when we're solving for sine, cosine, and tangent, right? SOHCAHTOA, the rules of math still apply. If we're looking for an angle, we're going to end up using the inverse of the property. If we're not, we're just isolating the variable. When the variable is isolated, the rest goes in the calculator. So let's go to our calculator. We press inverse sine. Make sure you add the fraction. On top we have 21 times the sine of 88. And in the bottom we have divided by 26. This gives us an angle of 53.8 degrees. Voila. Law of sines, you can find a missing angle or a missing side. Let's do one more just in case, just for practice. Remember, feel free to pause the video, give it a try, see how you're doing, and then let it play out and see if what I'm doing is the same as what you're doing. That's the best way to know if you're learning it. Don't just look at it and take notes. Try it yourself as well. So for this last example, feel free to pause it now and see if you can solve it on your own. Give it a go. Here we're looking for angle C. Across from angle C is side C. Across from angle B is side B. And across from angle A is side A. Notice how I'm missing two angles, so I can't add anything and subtract it from 180. So I'm ready to set up the problem and solve. Since I'm solving for angle C, I know I will use C as part of my equation. Sine C over C. Now I get to look around my picture and which set of information gives me all the information, the angle and the side. B is missing the angle, but A has the angle and the opposite side. So I'm going to use sine A over A. Once we identify the equation, let's plug in what we know. I don't know the angle, but I know the opposite side is 19. I know angle A is 97, but I don't know, and I do know the opposite side. Once your proportion is set up, cross multiply will give you rid of the fractions. 19 times sine of 97. Right? The cross multiply moves the denominator to the opposite side. Now to solve for C, get rid of the 22. We're dividing by 22 since it's the opposite of multiplying. Sine C equals 19 times the sine of 97 over 22. Since I'm solving for the angle, we have to get rid of sine. This is where we do the inverse. Inverse sine allows you to cancel the sine. And since we're doing it to the left, we're doing it to the right. Now that it's canceled, angle C is left alone. C equals the inverse of sine of everything here on the right. 19 times sine of 97 divided by 22. Let's plug it in our calculator and make sure you're using the correct sign, which is the inverse first. Inverse sine of 19 times the sine of 97 divided by 22. That gives us 59 degrees. Voila. Now, if we were interested in finding angle B, this is 59 degrees. Now you can subtract it from 180 because we have two sets of information. Right? Just in case we did want to get the full information, we have angle A, we have angle B, add them up, subtract it from 180, and that leaves you with the last missing angle. Alright guys, let us know if you have any questions. Don't forget to subscribe, and as always, we'll calculate later.